Hello, welcome again once to my channel where I try to provide you Oracle-related education for your professional and personal development. And if you like this channel, please subscribe. Do not forget to enable notifications so you stay informed of when I release new content. And like our videos and please share with your friends. So today I'm going to have fun with basic SQL, structured query language. SQL is a primary language that we use to query our relational databases. So this is a query language. However, there is a programming extension to SQL. In the case of Oracle, is a PL SQL. So the programming logic, it allows you to add a little bit of programming logic to SQL. Now I'm going to have fun. This is really basic SQL. And the reason I am doing this is because my son, he's 14, and he is beginning to get interested in what I do. And he is learning SQL. And in addition to that, he is an avid baseball player growing up. I'm crossing my fingers, hoping that maybe someday he can play at a high level. So our context for today, of course, we are in Minnesota, and Minnesota Twins happen to be our hometown team. So for the example, most of the example we're going to be using today would be related to the Minnesota Twins. And I'm not doing any publicity here by any chance. It so happens that that is my son's favorite team, and that team has his favorite players. So when we talk about structured query language, there are many parts to it. The first part, of course, you would have to create database objects. And in our case today, we're going to be having fun with creating a table that has some of the players of the Minnesota Twins. So what would be projected to be their roster for the 2022 year, and I am pretty excited about it. My son is pretty excited about it as well. So so let's get started. So the first part of this fun time demonstration would be data definition language. So data definition language, we are talking about creating, altering, dropping, or there is an additional truncate. So it's create, alter, drop, and truncate. So we are going to be creating. So now certainly the syntax for creating a table within the database is you create whatever object you are creating. So are you creating a table? Are you creating a trigger? Are you creating a procedure? Followed by the name of that procedure, and then certainly that table, and then certainly there are some specifics. So as in our case here, you would see here that I have, and I'm just going to put this in double ticks, and in SQL, when you have the double dashes in front of a statement, that means you're commenting out the statement, which means if you're running that statement, that part of that statement, it's going to be considered a comment, so it doesn't apply to your SQL script. So, and I'm using SQL Developer. For those of you who do not know how to connect to SQL Developer, certainly I have a video. I'm going to put the link to that video below this this video right here. So, so I have an example here that I'm just going to talk through it. So if we are creating a table, first of all, we want to create, like I mentioned, the object type. The object type we want to create is a table. And the name of the object is the Twins 2022. Now, in the interest of not making this long, I would have said Twins 2022 projected roster, but that kind of sounds a little long and boring. But I'm just going to keep it at Twins 2022. So for the specifics in creating a table, first of all, you'd have to define a few things. What would be the columns of the table under which you would be able to insert data for each row? In our case, the first column would be the jersey number for the player, of course, and the data type would be number. I would just keep that at 2 because I think our numbers kind of range from 1 to 99. I don't remember seeing any Twins player with a 3-digit number. And I would have that column marked as not null, which means that in the event that I am inserting data into this table, there must be a value for that jersey number, otherwise your insert statement is going to fail. And the different columns I am going to be including in this create table statement are separated by commas, right? And then at the end of the last column that I plan on creating, the comma is no longer there. So this would simply be just a closing of this open bracket that I started here and closing this bracket that I started here. So the jersey number would have a data type of number, which can take up to 2. The name of the player would have a character data type variable characters and can take up to 25 characters. The fielding of the player, that would be, is it a position player or a pitcher, or that basically would be the 2 options that I would choose. And for the variable type, I would choose to have that maybe at 25. Let's say 25 for now. Okay. And then maybe for the age of the player, how old are they? When I talk about age, I kind of remember that was a few years back when Torrey Hunter was still playing for the Twins. He turned 40 while he was on the team. So I don't think we have any baseball active players who are actively playing who are above 99 or in the 100 age range. That would be mightily spectacular, if you mind my redundancy. But Torrey Hunter was 40, and I remember when they were celebrating his 40th birthday, they gave him a walker and I think some diapers. But that's just for fun. And then the last column I would be creating would be batting. Batting now, are they batting right-handed? Are they batting left-handed? And that would take just one value for R for right and L for left. Okay, so if that statement is a correct statement, let's go ahead and run that. And then it tells me right here in my result that that twins table was created. Now let's go ahead and verify that. Now we can verify the structure of a table in SQL using the describe function. So we can actually either type it all the way out, describe, and then the name of the table that you want to describe. That way it tells you which of the columns that you are certainly going to be seeing. So if I run this describe statement, the output here simply just tells me what the structure of the table is. So it gives me the columns of the table, the different data types that these columns are associated with. And of course, if there are any constraints, it tells me here, like the not null constraint right here. So let's try a second example. We're still talking about baseball here. So let's just go ahead and create another table called baseball teams, so that we kind of see what this structure looks like. So I'm going to paste this right here. So create table MLB teams. Similarly, we have ID number, and the ID column, sorry, that takes a data type number, which can take up to 2 numbers. And also there's a constraint of not null. So typically when you're talking about constraints, not null plus unique constraints, the combination of those forms what we call a primary key. Abbreviation takes a variable character of length 5, and abbreviation would just be the abbreviation of the team. The conference is the conference in which the team plays, and the division, of course, is the division in which the team plays. So let's go ahead and run that statement. And then MLB teams has been created. So let's go ahead and describe and see exactly what that does. So we can use the fully qualified word describe, or we can use a short form of that word describe, MLB underscore teams. And let's take a look and see what the structure of that table looks like. So certainly, this is how we would create a table. Now, the second part of the data definition language. So the first part is create, the second part is alter. Now, what does alter do? Alter does modifications on the structure of the existing table. So you have a table that has a certain number of columns and a certain data type associated with each column. So if that is not the case, so for example, let me take out this and stick with the Twins 2022 table. And what if, for example, I wanted to make a change to, say, maybe the data type for the fielding column, Or say I wanted to add another column. In the example that I wanted to add maybe the batting average, a column for the batting average for these players. So that syntax for using the alter statement would be, so you alter the table name, and then you add. Now, if it's just one column, then it's the column and the data type. But if it's multiple columns, of course, you can separate those by commas up to the end. And then, of course, you close your SQL statements, of course, with your semicolon. So let's see how an example looks like. So I'm going to comment this out so that it doesn't run while I run my example. So assuming that I wanted to add a column on this table for the batting average. Now, let me just go ahead and copy all of this and talk through them. So what if I was going to add a column called batting average, which can take up to 3 characters? Now, of course, batting averages are 3 numbers. You know, it could be 100, it could be 300, it could be 240, it could be 480. You know, it's a percentage of how successful they are at the plate in terms of hitting. So assuming I wanted to add a column that added the batting average, and then I would just go ahead and run that statement, and it would tell me that the column has been altered. If I want to see what the changes are, I describe the, of course, Twins 2020 table, 2022 table. So that would be the batting average column right here has been added. Now, if you remember when we first created this, we only ended on at batting. So right now we have, when we describe it, we have a new column batting average that has been added. Okay. Now, if we wanted, of course, also to add, you know, a column called throwing. Are they throwing right-handed? Are they throwing left-handed? And then we go ahead and run this statement. It would have altered the table as well. So if we describe that table, we would see batting average, of course, added, throwing, of course, added. Let's imagine that we don't need, you know, those columns, right? But let's add a third column, or let's modify a column. Remember when I created this table, I created fielding with variable character up to 25 characters long. But I want to reduce that because we're talking about fielding. We're talking just about either they are pitching or they are a position player in this case. So let's go ahead and do that. So I would fix this statement and maybe modify the fielding. So if I describe this table right now, you see fielding currently has a variable character length of 25. But I want to modify that column and make it 15. So as I run that statement, it's altered, and I describe the table one more time. And right now we have fielding equals 15 in terms of variable character length. So I have my table sitting right here. So jersey name, fielding, age, batting average, and throwing. And then maybe say, for example, I imagine, you know what, I really don't need to collect that data about batting average. And this is just for demonstration purposes anyway. So we would drop that column batting average. So let's go ahead and do that. Sorry, I didn't need to put the data type. I'll just drop the column batting average, and it's going to drop, of course, all with its data type. Okay, so let's go ahead and describe that table again. So it almost resembles the original table, except we finally stayed with an extra column. After batting, we have the throwing. So we would keep this table as it is for now and continue with our different demonstrations. So we would move over. Now, there is a fourth data definition language called TRUNCATE, and TRUNCATE falls under this category because when you're talking about data definitions, the data definition statements, data definition language, when it comes to transaction control, or so either committing, being able to commit or rollback, data definition, once that statement executes, once it creates an alter, a drop statement, or a truncate statement, once that executes, there is an implicit commit, which means you cannot roll back from that that transaction. Okay, but the difference with data manipulation languages, which we are going to be talking about here shortly, is that, of course, until you commit, you still have the possibility to roll back if you figured out that you made an error. Okay, so the final aspect of our data definition we're going to talk about is a drop statement. So when you're dropping a table, the syntax would be you drop the object name and the object type and then the object name. So one of the tables that we had created before was the MLB teams. Let's assume we're going to drop this table for now because we don't want to do anything with this table at this time. So we are going to drop object name table, and then of course the object type table, and then the object name MLB teams. So if we run that statement automatically invalid drop option. So drop table MLB teams, it is supposed to work. All right. So I think one of the things I kind of, it came back to bite me and I thought I was going to be careful about it was I'm going to comment this out. So that would be the reason why, because this statement is trying to run these options up here and it complains that there is an invalid drop option. So let's go ahead and hit the command to run again one more time. And then of course, table MLB teams drop. So certainly that would be how you would drop. Now, when you drop a table, it typically goes to the recycle bin. Now you can flash back, you can recover that table from the recycle bin. But I want you guys to understand that, you know, DDLs have an implicit commit. So as you go about, you know, creating, altering, dropping, you know, tables, you want to be mindful of that. Okay, so that is a quick demonstration of create, alter, drop. We would truncate at the end. We would come back to the truncate option at the end, where we have had the chance to put some data inside those tables. So let's go back to our second part of our SQL, which is a data manipulation language. So by data manipulation, you can only manipulate data that is within a table. So you need to have data within a table to be able to manipulate it. In our case right now, we just created this table. Now, there is the most commonly or most popularly used data manipulation language, which is called select statement. The select statement, be it whether you are a DBA or a developer or anybody who is trying to read information within the database, by far you would use the select statement more than any of the other SQL statements. So, and the syntax for a select statement typically is you are selecting something from something. So let me put it this way, you're selecting something from something. So, and that something would be a table. So this would, I would say, table name. So basically you're selecting information from a table. So the format would typically be like this. Now in the something section right here, you could either select using what we call wildcards. So if I use an asterisk or a splash or a star, you can choose to call it however you want. But if I'm selecting using the wildcard star, it means I am selecting from every column that is existing within this table. Okay. Now, if I want to specify specific columns that I'm selecting from, and then I would select from column 1, column 2, and up the way to the last column. Let's say column, I'll put that in small letters N. Now, remember, you separate each column with a comma up until the last column before the from keyword. That does not need to have a comma, otherwise your SQL statement is going to fail. Now, this is a select statement in its simplest form. Now, if we are trying to sort the results of our query, then we would start using things like where conditions. We would have maybe, let me just put conditions in general, right? Where conditions could be a where clause, it could be a group by, it could be an order by, it could be anything. So you will start putting conditions. Typically, we use the where clause in order to add specific conditions for things that we are looking for. And maybe we would demo with a few examples. Okay, so I would comment this out so that as I run a few select statements here, these ones don't pick and try to run within the transaction. So we created a Twins 2022 table. So assuming we try to find if there is any information within our table right now. So we are going to select star, assuming we want to select from all, read data from all the columns from Twins 2022, right? All SQL statements, of course, must be followed by the semicolon at the end for it to be able to execute, or we can certainly use also the /. So select star from Twins, and I expect to find no data in here because we haven't put any data in here yet, right? So let's go ahead and run that statement. I'm not sure why it's not. Let's go ahead and run that statement with a semicolon. Oh, I think we still have to. All right, so it comes out here as an output. There is the column headings, but there is no data, and this is rightfully so. This is what we are expecting. So in the course of the rest of this demo, we would be running periodic select statements to kind of find out what we can find within these tables. Now, since we don't have any data within these tables, how about we insert a few pieces of data, shall we? All right, let's insert a few rows. Right now, the syntax for the insert statement, there could be a few, right? And I'm going to demo using all of maybe two common ones. So I'm going to comment this out so that, of course, it doesn't pick out these statements and try to run them and report invalid sequence syntaxes. So the first method of inserting is you can insert into what the table name is. So as we do that, let's go ahead and insert into a table name. We want to insert into the Twins 2022, right? And then if we are inserting a row which contains a value for each of the columns, right, we can just go ahead and use the keyword values. Now, what the database would understand by this is the values you are going to insert are for the rows in the same order that they appear on the describe statement. So if I go ahead and describe this statement one more time, and let me describe this statement one more time. So if I start inserting values in here, the first value is going to go for jersey number, the second value is going to go for name, the third is going to go for fielding, age, batting, throwing, in that order. So if I use this method, then I have to input values for each of these columns correspondingly, okay? So I have a sample statement here. I'm going to use this line first of all, and let's use this as our primary example here. So I'm going to cancel this out. So insert into Twins values. So it would understand that one right here is going for jersey number. Nick Gordon is going to go for name. Position is going to go for fielding. Either they are a pitcher or a position player. And then 25 is going to go for age. Left is going to go for batting. And right is going to go for throwing. So if I go ahead and run this statement, it is going to tell me if it is successful that one row has been inserted. Okay, now let us go ahead and test. Let's select star from our Twins table to see if effectively we see that one row of data. So this one row of data has effectively been inserted using our insert into statement. Now, the second insert statement, the second way you can insert would be to specify insert into table name. Now, You can use column 1, column 2. Now the values is going to correspond to the column in the order in which they appear. Okay, so if we take the second row right here, and I would modify this statement. So I would modify this statement. I'll control V. Now, instead of just doing values, I go ahead and put all the columns of that table in here. Now it makes it a little bit long. Let me just put this down here so that we, for the sake of visibility, we see that. So I would go with Jersey. That's the column, that's the first column, Jersey, and hopefully I spell it right. Maybe I should just copy and paste. That way I'm not making any mistakes. So let's do Jersey number. I copy that, I paste it. And then I do name, I copy as well, and I paste. I use SQL Developer because it's a lot easier with editing and managing my SQL statements. I do have a video for that if you're not familiar with using SQL Developer or creating a basic connection to your database. Like I mentioned earlier, I will add the link to the video below. So batting and throwing. So if I do this, what this statement understands is I am trying to insert values into twins table, and I am going to use these columns correspondingly to the values that, so Jersey number would be 2, name would be Luis Arias, fielding position, age would be 24, batting would be left-handed, throwing would be right-handed. So let's go ahead and do an insert of this. So it confirms here that one row has been inserted. Now, how do we verify that? Let's go back to our select statement. Select star from twins 2022. Now we have 2 rows that have been inserted. Now I would choose to use another example, and this particular player is new to the Twins, and this year that's one of the reasons why there is plenty of excitement, because this is a future Hall of Fame player. I may be wrong, forgive me, but I'm pretty excited about Carlos Correa coming to play shortstop for the Twins. And that is going to give the Twins a really, really dangerous attack and defense. Let's go ahead and insert into this. And I'm going to use this as an example to show you how this second way of inserting is going to affect this. So what if we are inserting this column and we don't want to put his age? So if we remove the age and just keep batting, so there has to be corresponding values to the rows that we are specifying on the insert statement. If I run this statement, I expect this statement to fail because, of course, it's going to fail with too many values. There are too many values for the corresponding columns that I have mentioned. Now, what if I also messed this up a little bit? So I removed from the fielding, which is position, I removed the age. What if I removed a data from here, a data type that doesn't correspond to the data type that we are trying to put for this column? So Jersey, if we go ahead and do a describe on these Twins, the data types that are being accepted for Jersey is number, which is okay, in this case 4. The name is okay, Carlos Correa. The fielding would take, this actually would work. So this is not a really good example. But let's assume that, let's remove that and maybe put 26 right here instead of right-handed. So let's do Jersey name, and then I remove the fielding, and then I leave the batting and throwing, which I would think would be corresponding entries. But now for the batting, the data type takes only a character of 1 string. And this statement I expect is going to fail because there is a constraint violation. it is asking for batting to have just one, but I'm trying to put 26, which is not a correspond, which doesn't, it is not validated by that constraint, that data type. Okay, so constraints are used in businesses, of course, to enforce rules and preserve data integrity. So this statement typically will fail. But what if I said, all right, I'm just going to put the name of the player and the jersey number, and then I expect this now to go because there is a corresponding entry for each of the columns that I want. Okay, so if I go ahead and run this statement, so insert into twins jersey, that, and I think I should take out this comma here. The expression wasn't right. So it's a little bit on the strict formatting side. So if you go ahead and run a select on this, you would see here that our insert has null, 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 null. Here is one more thing I want to do about another statement. So let's take a third statement here for all hey Polanco. Let's take a statement here for all hey Polanco. And now we are going to use this same method, right? We are going to put jersey name, field, let's say jersey name and all of that stuff. And then I hit enter. So now remember, there is a constraint. If we run a describe on this table, it tells us that if we are putting in a new row, there has to be a value for jersey. It cannot be not null. So assuming that I wanted to put in values for all hey Polanco, and I represented this as a null value, because of course in SQL that is represented as a null value. If I run this statement, I expect it to fail because there is a constraint violation. So cannot insert null into a not null defined column. Okay, so I want you guys to start playing around with this and making sure that you kind of understand what we are trying to do. So all hey Polanco wears number 11. So let's fix this and then insert the right data into that. And then if I run this statement, of course, right now, there is one row inserted. So there are many ways. I mean, you can pause this video, try a few examples so that you kind of understand the syntax of an insert statement. Okay. Now, in the interest of time, I would just go ahead and run the rest of the other statements, but I would have to come back to the Carlos Correa statement to make some modifications, and we would use that when we are running an update. So I would go ahead and copy all of this. Now, when you're running SQL statements, there is something we call transaction control statements. Transaction control statements basically control how you manage data as you go along with your transactions. So basically, we're talking about commit, rollback, and something we call SAVEPOINT. Now, SAVEPOINT just simply defines a point in your transaction where you can roll back to in the event that you make errors going forward. Okay, so let's go ahead and do this insert so that we can have a nice little table to look at. So I'll run all of the inserts and then I'll run the select statement in here to see, you know, what we have so far. So we've done 10 entries, we've created 10 rows. And at this point, let's say maybe we try to save up to this point. So I would create a save point. A save point has been created. The format is the save point command and then the name of the save point, right? So what if at this point, I start to insert maybe the next, let's assume 5. So 1, 2, 3, 4, 5. So let's insert up to this point. Let's insert up to this point. Let's insert up to this point. I'm going to insert all of these guys. And then I figured out, what happened? So missing comma, there must be something somewhere. There must be something somewhere. Let's go line by line so that I can see exactly which one is not right. So row inserted. There is a missing comma somewhere on one of these statements, and I would get that. Okay, that would be the statement that has an issue. So Tyler, so that one. Let's try to run the statement again and see if it's going to work. there's still a missing comma somewhere. So Tyler Duffy, he is a pitcher, all good. Yeah, so this is where there's a problem. So in SQL, you have to put string characters in ticks. So that statement would run now, certainly. Okay, so there is not enough values. That's because the 30 and the pitcher are kind of bunched together. So I would fix this real quick. It's an easy fix. And the 30 should not be here. So now that looks like a correct statement. Now this is showing you, of course, like we mentioned earlier, the power of constraints and data types. They enforce, of course, data integrity. So if I run this statement right now, then I expect this statement to run. Now, if I run this statement now and I figure, oh my, I run my select statement and I might have made some mistakes in, let's run my select statement right here. And I realize I might have made some mistakes with these guys. Now I have Alex Krylov twice, okay? I probably should go back to that save point, right? And this was a little bit deliberate so that we kind of know exactly. Now we're making a mistake going forward. Now, if I roll back without rolling back to the save point, I haven't committed any of the transactions from the beginning. So if I roll back, it's going to roll back everything that I have done. So I want to roll back to this save point. So the command I am going to use would be roll back to the name of the save point. So that would be the first 10 players. So if I click on that, it tells me rollback has been completed. Now, instead of seeing this result right now with Alex Krylov twice, Kirillov, if I'm saying the name wrong, I'm sorry. Then if I run a select statement now, I should see only up to the point where I created that save point, up to 10. Okay, so now you see how we can use save point. In terms of commit, if I am happy with the way my table is right now, I can go ahead and run a commit so that in the event that, you know, something happens, at least I have saved. Commit is synonymous to saving this transaction. So let's go ahead and click on that. So commit complete. So even if I exit the database right now, that that has made that transaction permanent, right? So even if the database shuts down and restarts right now, then the transaction has already been committed. It now becomes a permanent part of our data within the database. All right. So now that we've seen this, we've seen a commit. Let's do a few, you know, a few more. Now, if we run our select statement on our table, we have this. So let's go ahead and update this column and fix this, okay? Now, the update syntax, it's an interesting syntax, and I'm gonna do a couple to show you how those work, okay? So the update syntax, and I'm gonna comment this out so that it doesn't look at this as a bad statement. You are updating the table name, which is our twins 2022. And then I'm going to set a few columns, right? I'm going to set maybe column 1, which, and you can replace this, of course, with values, right? Here, I want to set the column for his fielding. So I want to set fielding equals the value for fielding. He is a position player and not a pitcher. So position, right? So if I go ahead, and again, with update statements and delete statements, you want to specify a condition. If you do not specify a condition, the whole of that column that you are setting will get set to the value that you're putting it in. So if I do not specify a where condition on this update statement, all of the fielding column is going to be replaced with position. Okay, now let's do that, and then of course we can fix that. So if I do that, it tells me 10 rows have been updated. That is not what I wanted. That is absolutely not what I wanted. So if I look at this, it tells me all this has been, all the rows have been changed to, all the fielding has been changed to position. And meanwhile, I had some pictures up there before. So if I realize that and I haven't committed this transaction yet, then I can roll back. I can roll back. And that is the power of rolling back. If I roll back, it tells me roll back complete. So I can go back to my select statement and see that, oh, I have, of course, the corrections have been, that change has been undone, basically. I'm going to copy this select statement since we're kind of trying to use it a little bit more down here. So with the update statement, there must be a where condition. So where, and again, we have, looking at the table, there are unique identifiers, right? So the jersey numbers for me would be the unique identifiers. So the jersey number, I would like to use that because that is a unique identifier for each of the different players. So where jersey equals 4. Now, what that means is if you take a look here right now, the fielding is null, age is null, batting is null, throwing is null. It's just his jersey number and his name. If I run this statement, it tells me here, it should tell me here that one row should be updated. Where jersey number, I should type better. So if I run this, it tells me here that one row has been updated. So if I run my select statement, I would see here that the jersey number, the position 4, Carlos Correa, has been updated to a position player. On the other side, I can as well run an update statement specifying more than one column. So let me copy this. I can run an update statement specifying more than one column. Since we've already made an update on the fielding position and we have to make an update on the age, set age equals to 20, how old is he? Carlos Correa, he's 26, and then he bats right, he throws right. So he is 26. All right. So 26, I separate them by columns. And then the second one I am trying to make is batting equals, he bats right-handed. And the last column I am going to update is throwing. And he throws right-handed as well, right? And then similarly, I specify my where to uniquely identify the row I am trying to update. So if I run this statement, then we should have one row updated. Certainly, if I run a select on this, I can definitely see that my table is looking pretty good at this point. So that is how you would do an update. Now, in terms of deleting, now you would delete entire rows. You cannot delete simple values within the rows. If you're deleting simple values within the rows, you would have to use update statements instead of delete. Now, the delete would delete entire rows as well. So if we're looking at the syntax for the delete statement, we want to delete from the table name, of course, specifying a condition. And I would show you here what happens when you don't specify a condition. And before I do that, please let me go ahead and commit this transaction. Let me commit this transaction and I run the SQL and it tells me my transaction has been completed. Now, I would comment this out and write a delete statement. So I would delete from our twins 2022 table, right? So, and I would specify where a where clause, say maybe where jersey, because these are the, or if I specify a condition that contains that applies to many rows, and all of those rows are going to be deleted. So assuming that maybe I run a select here, maybe let's see here where age equals, let's say 25. All right. If I say where age equals 25, what that does is it is going to, and let me double click here to sort this out. So all of these players who are 25 years old So Nick and Bailey Ober are going to be deleted. So where age column equals 25, that is a condition I'm trying to delete because, like I mentioned, it's going to delete entire rows. If I run this statement, 2 rows have been deleted, like I mentioned before, right? So these 2 position players, these 2 players who are 25 years old have been deleted. Now, I don't want that to be the case. So I would roll back that transaction. Okay, so you want to be very, very careful when you are running a delete. There must be a where clause pointing exactly to the rows that you want to delete. If I say where, maybe I specify a condition that applies just to one player, where jersey number, again, that would be my unique identifier. Jersey number equals maybe, let's say 18, Kenta, right? Assuming that Kenta is on the injured list for the beginning of the season, and he's not going to make the roster. But he's going to make the roster, but as an on injured reserve. 1 row will be deleted. So if I go ahead and select star from twins, that row has been deleted. Okay, so that is how you perform deletes. Now, if I do not specify a where clause on the delete, bad things are going to happen. And if I delete from twins without a where clause, watch what's going to happen. If I run this statement, it says 10 rows are deleted. I don't have anything left. So a delete from a table without a where clause is the same as truncating the table. Now, the difference is, of course, with truncate, it is implicit. You cannot come back from that. But with the delete, now that I figured out that that is not what I wanted, I can, of course, issue a rollback to get my tables back if I have not committed that transaction already. Okay, so I hope these examples kind of help you get grounded in everything that you need to do in terms of basic SQL. Now, this is basic SQL. If you want to get into too much detail on SQL, there are a variety of things that you can talk about when it comes to, structured query language and, the query language itself in things that it can do. So right here, I have up to 10, so what if I'm just going to maybe, in the interest of, getting my table completed, I think I already had these guys up here, the next 5, and then I have inserted the rows, and then from Max Kepler, all the way. So I'll start back from Ryan Jeffers all the way to the end. So basically, that is basically how you would, understand, create, alter, drop, and then of course, in terms of DML, insert, update, delete, and of course with the select statement. One other variation of your select statement, if you don't really necessarily want to select star, you can select specific columns that you want. Assuming that I was looking at my table and I said, hey, select star from twins, and then I want to specify conditions, right? Let's say where age is greater than, maybe I just want to see the guys that are true veterans within the team. Age equals greater than 30. Okay, I can put a condition like that. If I run that statement, it is only going to bring me players whose ages are greater than 30. If I say greater than or equal to, then it is going to add players that are 30. If I say greater than, this is mathematical, right? It means if you're 30, it doesn't apply. If you're 31, yes, it does. Okay, so this happens to include the pitcher, Tyler Duffy at this point. Now, I can also add certain where conditions, right? Multiple where conditions if I want, right? Where this age equals 30, and then maybe and, say maybe fielding equals maybe, let's say position, right? And then I'll put that in ticks, right? Position, right? Now, what happens here is I don't have any players, as you can tell here on my initial condition, who are older than 30 and are still playing positions, right? Which means here is, what I'm trying to get out of this, right? So if you want to play, long in the big leagues, then you want to play as a pitcher. So, and that's just my own, brutal analysis of this. So let's go down a little bit to 27. Let's do 27. Or let's do 26. Greater than 26 and are playing fielding positions. Absolutely. Greater than or equal to, or let's see, first of all, let's just make sure that this condition is right. Let's cut this out. And then where fielding equals position, right? I'm trying to see something here. It might be a little case sensitive on my keyword position. So I might be able to, change this here so that it gives me exactly what I'm looking for. Let's take a look at this now and see. Because that was kind of odd. So let's add that condition back to it where age equals 26 and fielding equals position. And then let's see, we have a few players that are there. So, and again, we can also choose to select, maybe just the name of the player and maybe the batting of the player from. And imagine when we are selecting more than one column, the last column before the keyword from doesn't have the comma, right? Let's add maybe throwing. Let's look at that. So that's going to keep out the jersey out of it, and it's going to keep out the position out of it. Okay, so here are some examples that you can use, and these are, if you work on this, try this set of examples of your own, create your own tables, insert your own data, mess around with this a little bit, like I told my son, then you would start understanding exactly how SQL truly feels. But let's go back to our select star from our twins table without any where clause, right? And then let's do the final demo in this exercise here, and let's do a truncate. Now, if you're looking at truncate, there is a format to truncate, right? So the format, the syntax to the truncate would be the truncate, the table, you're truncating a table, and then the name of the table. So, all right, so let's go ahead and mask this guys out here. So because we have our twins table now, if you remember, I told you if you run a truncate on the twins 2022 table, what is going to happen is that this table is going to be restored to only the structure. So truncate basically deletes all the entries, all the rows that are on that table, but it preserves the structure of the table. So with a delete, it deletes, of course, all the rows as well and preserves the structure. But the thing with the delete and the truncate is, with the delete, you can roll back. With a truncate, you cannot roll back. It is DDL. It is implicit. The commit is implicit. So if I truncate that table, the twins table has been truncated. Now there is no turning back to this. If I choose to roll back that table, if I run, first of all, a select star from twins 2022, I don't see any data. There is no data. If I roll back, I still will not see any data from that one. It will tell me rollback is complete, but if I go back and run a select, I still do not see any data within that table. So this, like I said, we're planning on having fun, and I'm sure we did. If you like the content, please go ahead, subscribe to the channel, like the video, share with your friends, enable notifications so that you stay informed of when we release new content. And I hope you are as excited as my son and I for opening day coming up this weekend coming, and I mean next weekend, of course. So thank you. Have a beautiful season. Have a good, lovely rest of your day, and I will see you in the next video.